Okay, so hang with me here in this, the last of our series of videos in calculating capacity and delay, and specifically the impact of the aircraft delay. In this video, we're going to get into using estimated delay cost to make informed, financially based decisions regarding investment in airport infrastructure. Now, just as a reminder of where we left off in the last video, this is a slide. This first slide in this video is the last slide in the last video. We wanted to review that to remind ourselves, remember what we determined, that operating our airport in our scenario with intermediate parallel runways at approximately 87% capacity could cost a minimum of about $1 million up to close to $4 million for delays in our particular configuration and capacity. We can calculate the cost savings of a different runway. So if we were to construct a new runway, we can calculate how much savings would be realized if we look at a different runway layout and the investment cost in that additional runway, and then compare the savings in delay to help us determine up front whether or not it is wise to make that investment. For our scenario, we evaluated the cost of delay for runway configuration number 3. Let's assume, just for our scenario purposes and just for calculation purposes, that we would consider constructing another parallel runway with greater distance between center lines that could be considered a FAR parallel with independent operations, as in sketch number 4. What savings would we realize? In the advisory circular, find sketch 4 and calculate the total annual delay in minutes as before. The mix index is the same at 40%. So use your 40% column or 40% row. Read the VFR, IFR, and ASV numbers, the annual service volume numbers, plotting them on your form as before. So we're going to put them in this. We're going to put these new numbers in the second row of our form here. The aircraft mix remains the same. The mix index, you see, remains the same. The configuration number, now we're going to evaluate configuration number 4. Notice that the VFR capacity for the current intermediate parallel and the VFR capacity for our proposed FAR parallel runways is the same. The VFR capacity is the same at 149 operations per hour. Why is that? Your PowerPoint explains why, and that is that both runway layouts are considered independent operations for VFR. So spreading them out further will not change that. It will only impact IFR capacity. So after noting that, notice that we'll calculate now the ratio of annual demand to the annual service volume, as we did before, obtain the average delay per aircraft and the projected delay in minutes, as before. In this case, we're obtaining, with the FAR parallel, we have our average delay per aircraft, low of 18 seconds, high of 1 minute and 18 seconds. Multiply that times our 250,000 operated annual or anticipated annual demand to get the actual or the estimated annual number of minutes of delay. Plot that information on our spreadsheet, and from there we take the estimated minutes of annual delay and we transpose that onto our other spreadsheet, and you see that we put it right the projected delay just underneath our current delay. We subtract the two and we come up with our percentage of savings in minutes. So with new constructing, instead of having intermediate parallel runways, we would construct a new runway to FAR parallel. We would have this potential savings in minutes. Multiply that times our cost per minute to get our projected benefit per year. Projected benefit per year. In other words, that is how much you would save per year at your airport if we used runway configuration number 4 far parallel instead of runway configuration number 3, the intermediate parallel. Now what we need to do is compare that savings to the estimates obtained for your construction project to determine how long it will take to pay for the airport improvements and decide if it is worth it. For example, suppose the estimated cost for runway construction to construct that far parallel runway, suppose the estimated cost for that runway was $20 million. It would save between about $400,000 and $1.4 million per year. With that new runway, we could reasonably then estimate it would take between 14 and 50 years to pay for the new construction. And with that data, now you know how much it would cost for the new construction and how much you would save per year in delay costs. You have data to help make an informed decision on whether or not to proceed with the construction projects.